Welcome back, everyone. Today, we're going deep on satellites.
Ooh, fun.
Yeah. We've gotten a ton of questions about them, specifically on the whole assembly process. And then also,
Yeah, antennas are a big one.
yeah.
I mean, they kind of make the whole thing work.
Yeah. How do they even work in space? It's crazy.
Right. It's mind-blowing, the engineering that goes into these things, to have them function flawlessly, millions of miles away.
Yeah. So much can go wrong. I mean,
Yeah.
have you ever thought about what it takes to actually build one of these things?
Well, it all starts with a purpose, right? You need a clear mission objective. What is this satellite actually going to do?
So, like, is it going to take pictures, like Hubble? Or is it going to be used for GPS? Or, like, weather forecasting?
Exactly. And once you know the mission, then you have to figure out where it's going to live, in terms of orbit.
Oh, right, because there are a bunch of different orbits, right?
Yeah, you've got low Earth orbit. That's
Yeah.
where a lot of the Earth observation satellites hang out. Then you've got medium Earth orbit. And then way out there, you've got geostationary orbit.
Right. And each one has its own challenges and advantages, right?
Absolutely. It all depends on the mission. You wouldn't put a weather satellite in low Earth orbit because it would only see a small part of the planet at a time.
Makes sense. So it's like a delivery truck, choosing the best route to get the package where it needs to go.
Yeah.
Perfect analogy.
Okay, so we've got the mission. We've figured out the orbit. What's next?
Design time. This is where we start breaking down the satellite into all its different subsystems.
So kind of like how a car has different systems for the engine and the brakes and everything.
Yeah, exactly. You've got the payload, which is the heart of the operation, then the structure, which is like the skeleton, the power system, the thermal control, ADCS propulsion, and, of course, communication.
Whoa, that's a lot of pieces.
It is. And they all have to work together perfectly, kind of like an orchestra. Every instrument needs to be in tune.
That's a cool way to think about it. So how do they make sure all these pieces actually fit together and work? Well, that's where the detailed design phase comes in. Engineers go through every single nut and bolt, making sure everything is going to work perfectly.
So they actually draw up blueprints for every little piece.
Yeah, it's incredibly meticulous.
Wow.
And they have to pick materials that can survive in space.
Right. We're talking extreme temperatures, radiation, solar flares, even tiny micrometeoroids.
Micrometeoroids. What are those?
They're like little bits of space dust, but they're zipping around so fast they can actually do some serious damage.
Oh, wow. So how do they protect the satellite from all that?
Lots of testing. I mean, they really put these things through the ringer.
Like what kind of tests?
Well, one of the big ones is vibration testing. They basically strap the satellite to a giant shaker and simulate the forces of launch.
Oh, wow, to make sure it doesn't rattle apart.
Exactly. And then there's thermal vacuum testing. They put it in a chamber that simulates the vacuum of space and then cycle the temperature from super hot to super cold.
Geez, that sounds intense. Like blasting it with a hairdryer and then throwing it in the freezer. Yeah, something like that. They need to make sure it can handle the wild temperature swings in space.
So it's kind of like space boot camp for satellites.
Haha, pretty much.
So once it's passed all these tests, then what?
Assembly time. This happens in a super clean environment called a clean room.
Why so clean?
Because even a tiny speck of dust can cause problems, if it gets in a sensitive instrument or a short circuit something.
Oh, right. I guess you don't want your $1 million satellite failing because of a little dust bunny.
Exactly. So everyone has to wear these special suits, and the air is constantly filtered to keep everything super clean.
So it's like a giant operating room for robots.
Yeah, kind of. Technicians work incredibly carefully, connecting all the components, running tests at every step, making sure everything is absolutely perfect.
It sounds like building a satellite is kind of like a giant 3D puzzle.
It is a very expensive and a very complicated puzzle.
Right. Speaking of complicated,
Yeah.
I'm really curious about those antennas.
Ah, yes, the antennas. Those are crucial for communication. Sending and receiving data back and forth to Earth.
Right, like without antennas, the satellite is basically useless, right?
Pretty much. It's like having a phone with no service.
So how do they design antennas that can work in space? I mean, it's not exactly like putting an antenna on your roof, right?
No, it's a lot more complicated than that. You have to consider things like the frequency of the signal, the distance it needs to travel, and of course the harsh environment of space.
Right, because there's no air to carry the signal.
Exactly. It's all about electromagnetic waves.
So what kind of antennas do they use?
Well, there are a bunch of different types. It depends on the specific mission and what the satellite needs to do. Some antennas are highly directional, like a laser beam focused on a specific ground station. Others are omnidirectional, sending and receiving signals in all directions.
Oh, I see. So it's kind of like choosing the right tool for the job.
Exactly. And once they've picked the antenna, they have to make sure it's pointed in the right direction.
That sounds tricky. I mean, these things are moving pretty fast.
It is. They use sophisticated systems to control the satellite's orientation and keep the antenna locked onto the target.
Wow, so it's like a constantly moving target.
Pretty much.
This is fascinating stuff. But how do they even get the satellite up into space in the first place?
Well, that's a whole other story.
I bet. So I guess we'll have to save that for another time.
Yeah, next time we'll talk about launch and deployment. Stay tuned.
Sounds good.
All right, so we've built this amazing satellite.
Right.
We've tested it, made sure it can handle the rigors of space. But now we got to get it up there.
Yeah, that's the tricky part. How do they even transport these things? I mean, are they just like strapping them to the roof of a car?
Uh-huh. Not quite. It's a lot more delicate than that.
Yeah.
Think of it like this. We're basically moving a super sensitive, extremely expensive piece of equipment. So it's got to be protected from even the tiniest bump or vibration.
I bet. So how do they do that?
Well, they use these special climate-controlled containers. They're like high-tech cocoons that keep the satellite safe and sound during transport.
Huh. So it's like a first-class flight for a satellite?
Pretty much. They even monitor things like temperature and humidity to make sure the environment is perfect.
Wow. Talk about pampered. So once it gets to the launch site, then what?
Then the real fun begins.
Uh-huh.
We have to integrate the satellite with the rocket. That means mounting it to a special adapter and then encapsulating it within a protective fairing.
The fairing, that's the nose cone, right?
That's the one. It basically acts like a shield protecting the satellite during the violent ascent through the atmosphere.
I see. So it's like putting on a suit of armor before going into battle.
Exactly. You gotta protect your precious cargo. And before we even think about launching, we run through a whole bunch of tests again, just to be double, triple sure that everything is still working perfectly.
Oh, right. All those vibration and thermal vacuum tests.
Yep. Gotta make sure nothing got jostled loose during transport.
So it's like a final exam before graduation.
You got it. And once it passes all the tests, well, then it's showtime.
The launch. Man, I bet that's an incredible sight to see.
It is. It's a carefully choreographed ballet of engineering and precision. And of course, there's always that element of anticipation and excitement. You know, years of work all culminating in this one moment.
I bet. So what happens during the launch? Like step by step?
Well, first they fuel up the rocket, and then they go through a series of final safety checks, making sure everything is green for go.
And then they just press the big red button.
Haha, not quite. There's a whole countdown sequence. And the weather has to be perfect, too. You know, no high winds or thunderstorms.
Oh, right, because I guess the little rain could mess things up pretty badly.
Yeah, it's all about minimizing risk. But once everything is in place and the countdown reaches 0, boom, those engines ignite. And it's just the most incredible surge of power you've ever seen.
I bet. So the rocket blasts off. And then what?
Well, the satellite is still tucked away inside the fairing at this point. You know, it's got to ride out the first part of the journey nice and protected.
Right, because things get pretty rough during that initial ascent.
Yeah, it's a wild ride. But once the rocket reaches a certain altitude, the fairing separates and the satellite is exposed to the vacuum of space for the first time.
Whoa, that must be a pretty big moment.
It is, but the journey isn't over yet. It still has to reach its final orbit.
Right, so how does that happen?
Well, it involves a series of carefully timed maneuvers using small thrusters on the satellite. It's like a delicate dance nudging it into the right position.
I see. So it's not just like pointing it in the right direction and firing the engines.
No, it's a lot more nuanced than that. It takes a lot of skill and precision to get a satellite into exactly the right orbit.
So once it's in orbit, then what? Does it just start working?
Not quite. There's still a very important phase called commissioning.
Yeah.
This is where we basically wake the satellite up and get it ready for its mission.
Oh, right. Like booting up a computer for the first time?
Yeah, exactly. We deploy the solar panels, make sure they're generating power, and then we unfurl the antennas and establish communication with ground stations back on Earth.
So it's like a final systems check, making sure everything is running smoothly.
That's it. And this is where those antennas we talked about earlier really come into play. You know, they're the satellite's lifeline to Earth, allowing us to send commands and receive data.
Right. So we've talked about how important antennas are, but can you tell me more about like the specifics? What makes a satellite antenna different from the one on my roof?
Sure. Well, for starters, satellite antennas have to be a lot more powerful. They need to transmit and receive signals over vast distances, sometimes millions of miles.
Wow, that's crazy. So it's not just about picking up a few local channels.
No, not at all. And they also have to be incredibly precise. Even a slight misalignment can cause problems.
Oh, right, because I guess the signal is like a really narrow beam.
Exactly. It's like aiming a laser pointer at a tiny target from miles away.
So how do they make sure the antenna is pointed in the right direction?
Well, they use sophisticated attitude control systems that constantly monitor and adjust the satellite's orientation. It's pretty amazing technology, actually.
It sounds like it. And what about the physical construction of the antenna? Like, what's it made of?
Well, they use all sorts of lightweight but durable materials like aluminum and carbon fiber. And sometimes they even coat them with gold to improve their reflectivity.
Gold, God. Wow, that's fancy.
Yeah, gotta use the best materials when you're building something for space.
So it sounds like there's a lot more to satellite antennas than meets the eye.
Oh, absolutely. They're a crucial part of the whole system.
Yeah.
And there's so many different types and designs depending on the specific mission.
This is all so fascinating. I'm really starting to appreciate the complexity of these machines.
Yeah. It's mind-blowing when you think about all the different pieces that have to come together perfectly for a satellite to work.
Right. And we haven't even talked about the science that they do once they're up there.
Exactly. But I think that's a story for another time.
Yeah, we'll have to save that for our next deep dive. It's amazing, right? All the work that goes into designing, building, and launching these things.
Oh, yeah. It's a massive undertaking. But it's so rewarding when you see it all come together.
Yeah.
And the satellite is up there doing its thing.
Absolutely. It really is a testament to human ingenuity and our drive to explore.
I couldn't agree more. And the best part is the technology is constantly evolving. We're always pushing the boundaries of what's possible.
So, like, what are some of the new things on the horizon that you're excited about?
Well, one of the big trends is miniaturization. We're seeing more and more of these tiny satellites called CubeSats and nanosatellites.
Yeah, those are pretty cool. They're like the size of a shoebox, right?
Yeah, some of them even smaller. But don't let their size fool you. They're packed with all sorts of sophisticated technology, and they can do some pretty amazing things.
Like that.
Well, they're being used for all sorts of missions. Earth observation, weather forecasting, scientific research, even testing new technologies.
So it's like having a whole army of tiny scientists up there in space.
Exactly. And one of the great things about these small satellites is they're relatively inexpensive to build and launch.
Oh, right, because I guess size matters when you're talking about rockets.
It definitely does. So
Yeah.
this means that more people can get involved in space exploration. Universities, research institutions, even startups.
So it's kind of democratizing space.
Yeah, exactly. It's opening up a whole new world of possibilities.
That's awesome. What about AI? I've heard a lot about AI being used in space these days.
Oh, yeah. AI is a game changer. It's
Yeah.
being used to make satellites smarter, more efficient, and more autonomous.
Autonomous. So, like, they can think for themselves?
Well, in a way, yes. They can make decisions and adjust their operations based on the data they're collecting.
Wow, that's pretty mind-blowing.
It is. For example, AI can help a satellite identify and track space debris, to avoid collisions.
Oh, right, that's a big problem these days.
It is. And AI can also help satellites process vast amounts of data in real time, like analyzing images or detecting patterns.
So it's like having a supercomputer on board the satellite.
Pretty much. It's really incredible what AI is enabling us to do.
It sounds like we're entering a whole new era of space exploration.
We are. And it's an exciting time to be involved in this field.
Absolutely.
Yeah.
Well, I think we've covered a lot of ground today.
We have, from the nuts and bolts of assembly to the amazing future of AI and miniaturization.
It's been an incredible journey.
I agree. And I hope our listeners have enjoyed learning about the amazing world of satellites.
I'm sure they have. So until next time, keep looking up at the stars and wondering about all the incredible things happening out there in the vast expanse of space. Thanks for joining us on this deep dive.